Okay, our next speaker is online, remote,
Radin.
Dean Radin of the Institute of Noetic Sciences. There he is. Take it away, Dean.
Thank you. Let me share my slides. There we go. Okay, let's move this over just a bit. Should that, okay. Actually, my talk is like an extension of the previous one, which I found very interesting because I too have made a little optical interferometer inside a box, somewhat different than what you just heard about, but I'll be using that for experiments of the following type. So all of this, I'll do a quick recap. There we go. 7 years ago, I gave a talk at the Tucson conferences on double-slit optical systems used to test the consciousness collapse hypothesis. And this idea comes about because of the puzzles involved in how do you transition from quantum potentials into classical actuals. It's sometimes thought about as where does the chain break between quantum and classical. The sketch was drawn by John Bell, who was one of many people who worried about this problem. John von Neumann suggested that the measurement chain ends with knowledge of the measurement as registered by an extraphysical event, by which he meant consciousness. And he wasn't alone in this. Many people have thought about this and suggested similar things. You go to Wikipedia and you look at the various interpretations of quantum mechanics. There's consciousness causes collapse. And if you survey contemporary physicists, you find that roughly 22% agree with John von Neumann and others at saying the observer has a distinguished physical role in some way. Even Dave Chalmers and Kevin McQueen have a very nice chapter in a book about consciousness and the collapse of the wave function, in which they write that the upshot is not that consciousness collapse interpretations are clearly correct, but that there is a research program worth exploring. And that's what I've been doing. So there's a double-slit optical system. We're all aware that if you don't gain which path information, you get an interference pattern. And if you do, you get a particulate pattern in proportion to which you gain the information. So the first experiment to look at this explicitly with a double-slit system was in 1998 with Stan Jeffers at York University and Mike Gibson at Princeton University. That's a sketch of what their system looked like. They were looking at fringe visibility. And so the York University studied it 74 sessions with a number of people, and they found overall no significant change in the interference pattern and fringe visibility. And at Princeton, they did find a significant result. Post hoc, the York University results are a little bit odd because it showed significantly elevated variance in the results as compared to the control runs, which showed no change in variance. And I'm going to return to this later. So the third replication are the studies that we began in 2008 and are continuing to the present day. Again, using a very simple double-slit system, except that we primarily focused on meditators. And we would ask the meditators in their mind's eye to imagine that they could see a double slit. And they would then be asked to sometimes look at it in their mind's eye and get feedback, typically real-time feedback, or to withdraw their mind. And so we use that differential as our primary measure. So there's a holder of a double slit system. You can see the slide sort of sticking out. There's a line camera that we use. This one at 3,000 pixels in a row. There's what the camera saw, light and dark bands. This is a way of looking at it on a graph. That's how the experimental system, our first system was devised so that everything is sealed inside the box. Can't really see anything directly. This is a later system we built out of parts that we bought from an optical company. It unfortunately costs around $10,000 if you want to make this yourself in the laboratory, if you want to make a really good one. And so again, this is what a graphical version of the intensity level looks like for the interference pattern. What we did many different kinds of analyses, but this one was the simplest, where you simply take a Fourier transform of that shape on the left, and it gives you the shape on the right, which is the spectrum of the different patterns. So this pattern here is the double slit component of that interference pattern. And so the hypothesis is that if you focus your mind on the double-slit system, that it would cause the double-slit component to begin to go away, in which case the arrows here that you see on the right would begin to change from a position where you're not observing the system with your mind. So the protocol is very simple: compare interference during observation versus no observation, typically around 30 seconds at a time, and you repeat this typically 20 to 30 times in one session. It's a differential measure, and the prediction's very clear. We predicted originally mental observation would reduce interference. So we did a bunch of pilot tests with all participants. They're splitting out the non-meditators. There are the meditators. The experiments use the same apparatus, but different protocols. And we also did a bunch of control tests where the apparatus was running the same way with the same computer and everything, but with nobody trying to do anything to check out the protocol and the equipment. And overall, these are one standard error bars. You can see overall, the meditators did quite well. Even all participants together did pretty good. Non-meditators by themselves did not do so good, but the controls were well behaved. We then were advised to take what we had learned and do a formal test, which meant to do 50 planned sessions with people who had done well in the previous test, selected participants. So that's the results that we got. Experimental results are about 5 sigma below chance, and the controls are almost exactly at chance. So then the question was, well, maybe this is due to the proximity of the human body. Not quite the same as the previous talk, because there was no manipulation of consciousness, whereas in our study, we're asking people to focus toward and away to see if there's some causal link with intention. But nevertheless, we're within 2 meters of the apparatus, and temperature is a factor that will change into how the interference works because of the electronics. So we created an online version of this. We ran this for 3 years. We allowed people to fly in through their browser. People would either observe during a no mental focus condition, just a blank square, or they would get real-time feedback about what was going on in the interference pattern. So there'd be an observing and non-observing periods for humans. And then we also programmed a Linux box to do the same thing. The double-slit system, of course, did not know who was looking at it, so it provided a very nice control. The measure in this case was fringe visibility. So it's just looking at the maximum and minimum. And the hypothesis was that when humans were looking at this and doing the task, fringe visibility would decline. So that's what we expected to see, and that's what we saw. So people looking at the system, this is in terms of z-scores. We saw sometimes some of the fringes. We're looking at the 20 middle fringes of the interference pattern. When the Linux box looked at it, we did not see that. So something about what humans were doing made a difference. We knew where they were looking or where they were from because we had their IP address. And this is dots indicating all the results from around the world. This is what you expect by chance. And this is the results we actually saw. This is taking all of those dots and making a linear correlation, and it is flat to 6 decimal places. And what that tells us is that the effect that we were seeing was consistent and independent of distance. So the next question that somebody asks is, well, what about single photons? So we'll be sure that it's really a quantum effect and not just a statistical effect. So we used a commercial device, which allows you to do a single photon double slit. We used an enhanced feedback design where success was indicated by a Buddha doll that was illuminated. So we called it the illuminated Buddha. The better you did in this test, the brighter the Buddha would get. We were able to check that the device was working in the way that we thought it should. In other words, that we would get an interference pattern as you move the photomultiplier slit back and forth over just like a couple of millimeters, but you can see the development of the interference pattern. So the experiment had 20 participants, each did 1 session. We put the slit over a dark spot in the interference pattern, and if they were able to disrupt it, then the number of counts per second would increase. And that is in fact what we saw, a significant increase in counts. So the fourth, so we did a bunch of studies. We did something like 17 or 18 experiments with different kinds of lasers and different protocols, all kinds of things. The next replication was by Gabriel Gruer, who's a physicist who was at CERN, who decided that what we were doing is more interesting. So he spent a month in our laboratory to look at what we were doing and the methods of analysis. He went back to the University of Sao Paulo, where he created his own system from scratch. And there he is setting it up. He then published this as an archive. It's not formally published yet, but what he reports in there, this is back in 2018, he did 6 exploratory mode tests, very similar to the kinds of experiments we were doing, and found very strong, statistically significant, unidirectional, meaning a mean shift effect, the interference pattern going down, differences. Then he did 3 formal experiments, did not get a statistically significant result, until he looked at it post-hoc and found he got a significant result in variance. So again, going back to variance, later we also looked at some of our data and found very significant effects in variance, and I'll explain at the end why we think that's the case. Another replication was reported in 2019. This was some Vucanics group at a university in Serbia with collaborators in a university in Moscow. They had 26 participants. They also took EEG while their people were doing a double-slit kind of experiment. The results was their experiment confirmed that attention affects the electromagnetic wave, causing wave function collapse in a double-slit optical system. They went on to say that the results published by Professor Radin and co-authors showed that the z-score of interference magnitude and phase was largest with data lag 3 seconds, as was the case in our experiment. What that refers to is that it takes a little bit of time when you're asked to now stop concentrating, or now you can relax. It takes a few seconds for you to mentally be able to do that. So we introduced a lag in the analysis of the results, and they did the same thing, and that's where they found the maximal effect. They also said that we had observed significant changes in the electric field ratio and the concentration for a relaxed condition, which is what they observed in their study as well. So we were using a ratio measure and found that there was a significant difference there too. Well, so that was nice. We found this by accident. A colleague of ours happened to notice that my name was mentioned in an experiment, and sure enough, it was this one. So and here are all the published experiments that we know of at this point that have done experimental tests like this. There are 30 reported experiments, 14 are significant at least at the 0.05 level two-tail, and if you do an exact binomial test on this, it's about a 6 sigma result. Last year, or no, sorry, a couple of months ago, beginning of this year, there was this paper published with a somewhat unusual title, but what it is a review of all of these studies, these double-slit studies. And their bottom line conclusion was, contrary to the common belief that physical events have a unidirectional first-order causal effect on cognition, these studies suggest that mental activities are capable of influencing physical systems. So the present paper provides an extended review of findings on this psychophysical phenomenon, as well as recommendations for future research. In this review, they did not know yet that there was this 2019 replication, because I hadn't found it either. I did not know that these folks in Ireland were doing this review, but they found almost all of the published data except that one. So to back up a little bit, all of this sounds like, if you had never heard about studies looking at mind-matter interaction, you would think that this might be interesting, kind of intriguing, because it's addressing observer effects and the measurement problem. But within parapsychology, people have been talking about this in some detail since the 1950s. So this was a publication of a conference in the 1950s, another one from 1974, where Gerald Feinberg was there, Costa de Beauregard was there, Harris Walker, Helmut Schmidt. This has been discussed again and again about the idea that there is something interesting about quantum mechanics, which most of the founders of quantum mechanics were already talking about, not just John von Neumann, but lots of others, suggesting that there's some peculiar property of consciousness that is involved with the behavior of the physical world. As you're probably all aware, at the Princeton laboratory was working on this issue for 30 years. They used quantum-indeterminate randomness as a way of studying it. And what they would find in their experiments, this is just one of many experiments, that if you are causing a machine to produce truly random bits that are based on quantum events, and you ask somebody to mentally intend to get ones, then you cumulatively will get ones. And if you ask for zeros, you get zeros, and under baseline, you get a baseline result. So there's a lot of evidence. This was our review back in 1989 on this body of data. Unequivocal positive results in experimental conditions. We found 800 such experiments published by a bunch of people, and controls didn't show anything interesting. So since this had been talked about from the 1950s, eventually there came this idea of the observational theory developed by parapsychologists, mostly physicists. And the idea was the act of observation by a motivated observer of an event with a quantum mechanically uncertain outcome influences that outcome. So these influences are presumed to be quantum mechanical and are not constrained by ordinary space or time. In particular, it predicts that there should be a retro-psychokinetic effect. In other words, you could record unobserved random data, later play it back, and when you're playing it back, ask people to influence it then. So that's why it's called a retroactive effect. So this is kind of a delayed choice version of a random number generator experiment. I had done one of the pilot studies that I did with the double-slit system was a retroactive effect. And while it wasn't statistically significant, it was in alignment with the direction of the results we saw in the other experiments. So at the very first Tucson conference, it's either maybe the first or second, 25 years ago already, Dick Bierman from the University of Amsterdam gave a meta-analysis, which is this table of all of the studies conducted from 1975 to 1993, looking at this retroactive psychokinetic effect. And overall, it's a 5 sigma result. It's been repeated a number of times. And most importantly, this is the first parapsychological theory that is led to a prediction and subsequent confirmation of a new effect, retroactive psychokinetic effect, that was not previously observed because no one thought to look for it or even imagined, and yet it was found. So when you think about the power of theory, this theory predicted something that no one had seen before, and in fact, it was found. So when people sometimes say that parapsychology doesn't have any theories, blah, 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 that's not true. So to find out, to read about this in much more detail, I would recommend using Google to look up Retroactive PK Project, which will bring you to this Formilab website. And then there's a whole bunch of information with explanations about how this experiment works and what the results are and so on. So the summary then is about 90 years of experimental evidence for the reality of certain kinds of mind-matter interaction. It provides growing support for the consciousness collapse hypothesis, but more generally, the idea that consciousness plays a role in the physical world. And in experimental tests, we find that significant variance effects are more common, and I think they're probably due to mind wandering. After all, you're asking somebody to do a fairly abstract task, put your mind over there and do something with it, and do it for like 30 seconds at a time. Well, we know from studies of even long-term meditators that it's really hard to do that. Your mind starts wandering. The difference between a meditator and a non-meditator is that a meditator will recognize their mind wandering and they'll return, whereas a non-meditator won't even recognize that they're mind wandering and they'll just go off somewhere. So if you think then about what that would do to a system, you attend to a system, the interference pattern changes. Well, you start drifting and the interference will go back to where it was. Oh, you come back to the task. So over the course of 30 seconds, you might go forward and backwards from the task 5 times, 10 times. That would create a variance effect that you would not see in a condition where for 30 seconds, you're thinking about something completely different. So that's why I think we see these variance effects. So acknowledgements for all of the foundations and individuals have supported my work. Other people, of course, other foundations have supported the work from other people. And with that, I'm going to stop. And I thank you for your kind attention. And let's see. I now need to stop sharing. There.
Thanks so much, Dean. Okay, let's have a brief question session for both Dean and Santosh. And Santosh, you can come up here. And I have a quick question for both. These are very similar physical systems that are making these measurements. Would it be worth, or is it possible to create an extremely precise physical system doing the same thing such that you could calculate from first principles of physics exactly what the interference pattern should be and measure it precisely enough so that you could then measure variances from the precisely calculated first principles of physics results that you'd expect from when there's no observational effect?
Well, from first principles, probably not, because there are too many things that we don't understand yet. Like we don't understand why consciousness would have this effect. But can we get close to that? Yeah, I think we probably could.
No, but I mean a very precise device such that you could calculate from first principles exactly what the pattern would be when there's no conscious effect.
Oh, yeah. No, you can do that purely in mathematics. Yeah. And I mean, the $10,000 would give you a device that's more than sufficient to be able to measure that.
Yeah. I mean, if you're asking me that question, my device is a very low budget device. It's actually ridiculously simple, but it gives you a robust effect that does not rely on statistics at all. It's purely all or none, as I said. And just yesterday, we recorded from somebody here, and we got a nice result again. So it's very reproducible and robust. So I don't know how, well, we could increase the sensitivity of my device to detect very tiny changes in consciousness, I guess. So that would be one direction that we would want to go. The effects that Dr. Radin talked about were 2 meters, I mean, they were at a distance. So I think so in our case, the effects are fall off with distance, but the distance to which you see a robust effect is up to about 30 centimeters, maybe 90 centimeters. Beyond that, you see asymptotic kind of an effect, which is what I think they're capturing. And it's very important to sort of do what they're doing with our device at that longer distance. And we might be able to get some common answers to his observations. But at the very close distances of 15 centimeters or 5 centimeters, it's a very robust effect that we get just from pure, these people that we recorded from were not doing anything. In some cases, they were even going to sleep momentarily while we were doing that. So you always, yeah.
The reason I found what you're doing so interesting is because I too, as I said, I've made an optical device where previously I was never able to get somebody close to it.
Yeah.
You know, there were fairly large systems or so sensitive that you couldn't do that. But now I have an optical device in this that I made, so I could put it here.
Yep.
And I should be able to replicate what you've been seeing, because I have lots and lots of other sensors in here to look for changes in temperature and so on.
Yeah.
And I could do the mu metal inside and all the rest of it. So I should be able to replicate what you found.
And you will get exactly what we find. I can guarantee that.
I look forward to doing that. It's fascinating.
Yeah. Thank you.
Okay, over here, there's a question.
So I think both of you are certain that you have no physical effect between the human brain and the sensor. So is there, no regular electromagnetic effect?
No.
So is the postulation that this is some sort of superposed gravitational field that is coupling the two together? And I did calculate it about 2 years ago. So in our little experiment with the mirrors, you're talking about nearly 1 kilometer before you hit the Planck constant, i.e. that you would have no measurable difference in space-time. So it potentially is quite a long effect.
Mm-hmm. Thank you.
Yeah, so in our online study, the farthest distance was 18,000 kilometers from our lab, and the results from that did not show any statistically significant difference from somebody 2 meters away.
Yeah.
So is it gravity, quantum gravity? I don't know.
Yeah. My sense is that what they're recording is an asymptotic effect which goes to infinity, basically. Or at least, I don't know, 20,000 kilometers. But there's no reason for it to level off and become zero. The kind of thing but for the kind of thing that I'm measuring, it is 15 to 30 centimeters, and you see a robust response to it.
Santosh, did the anesthesia, it actually, the signal went up?
Down. It went down.
Down.
Yeah, you were not paying attention this time. So
I thought ketamine went up, xylazine went up?
No, both in all anesthetics that we have tried, including pentobarb, the amplitude goes down. The thing that changes, the rise time becomes small. So it's rapid, more rapid rise, but it plateaus at a much lower amplitude. And the rapid rise, I think, can be explained by synchronization of the collapses. Okay. Whereas when the brain is intact and unanestheticized, you get patterns, you get desynchronized patterns, and that happens in EEG as well. And yeah.
So if it goes down with anesthesia, you have a potential anesthesia depth monitor. That might
absolutely,
okay.
Absolutely.
Yeah, I'd like to hear more about it. And in response to Dean and what James said, I think it's possible that in our theory anyway, the superposition in the brain can entangle with the superposition in the system, and at some point they're gonna add and reach a threshold and have a collapse themselves. So that could explain it. Whether it does or not, I don't know.
That is actually the conclusion of the folks in Serbia, that their assumption is that there's an entanglement going on, and that's why you see these effects.
Yeah, one last comment I want to make. It's kind of the way I look at it, it's a synthesis between what they're measuring, which is that consciousness causes collapse, versus collapse causes consciousness. It's kind of an amalgamation of the two. Both, yeah, they add up. So, yeah, that's the best explanation for at least our data. Yeah.
Yeah, so this question is for Dean. I really admire your work, and I think it's a very important work you're doing. But I just have a question, because I was actually, one day I was talking to a professor in Santa Barbara about your work. And so they sent me this article published in 2019 about showing some of your results is a false positive effect. So they did some analysis, used advanced experimental protocol, and showing your result could be analyzed wrong. Have you read that paper, or what do you comment on that?
Yeah, I'm familiar with that paper. Mm-hmm. There was one thing mentioned in that was probably correct, and could lead to a false positive result. There was also a significant difference in that study, which was designed by the funder, not by me, in which we did not provide real-time feedback. In retrospect, that was probably a mistake, because it's difficult for people to do the task, right? It's 30 seconds to do something, and in this case, with no feedback at all. So there's probably a lot more mind wandering going on. Later, we went back and looked at the data to see if we did get a significant variance effect rather than a mean shift. We got a very significant variance effect in that study, along the lines of what the original idea was looking at, which was different ways of providing the instructions of what you're supposed to do, focus towards, focus away, and various combinations. And there we found results almost exactly what would have been predicted if we had used a variance effect rather than a mean shift.
Mm-hmm. Yeah, and also, so we have actually recently come up with a holographic quantum theory of consciousness. So in this theory, we find that actually all the observed physical phenomena is manifested by our own consciousness. So we have mathematical formula actually to show how the consciousness affects the observed physical phenomena. According to our theory, is so basically actually double-slit double-slit interference pattern is actually, that is part of all all the observed phenomena is manifested by the consciousness. However, so our consciousness, there's two kinds of consciousness. One is the duality consciousness, which is manifest, the different like gravities or different phenomena. But then if you are able to go into the emptiness, 0 point, those kind of empty consciousness, then you will be really, your ability to change the physical phenomena then you have the ability to do that. And so you are using the people has, of course, when you do the meditation, then your ability to change physical phenomena is higher. So actually more advanced masters, with meditation or high spiritual masters, then they will be able to really change the physical phenomena with a greater capacity. So maybe you can maybe do some experiment with advanced master to see.
Of the advanced masters that I know, they generally are not very interested in doing experiments, especially in the laboratory.
Yeah, actually, I find some master. I talk to them; they're willing to do it. So if you would be interested, I'd be happy.
Well, this is one of the reasons why I made a little box, right? Because then they don't have to come to the lab. I can send the box to them, and then they could do the experiment.
Okay, yeah. So we have a lot of healers. Maybe we can test whether they have this ability. Or some masters that might be.
Okay, let's thank Dean and Santosh again.
Thank you.
And now,
Thank you.
is there one more quick question? Quick question.
Hi, thank you. Sorry, I've had this question from the first talk, and then the second talk just made my question even bigger because of how you two connected, which I really appreciate how your talks had so much synchronicity. So I was actually wanting to kind of segue from what Daniel was talking about artificial intelligence and really how human consciousness could really be unique from anything that we create with AI. So I wanted to emphasize, you had the Linux protocol, which wasn't able to have the results for the intentionality, creating the conscious outcomes. And then with the little box, my question was, what happens, have you ever thought about programming the workers coming in and seeing the consciousness level rise? I wonder if it's possible using intentionality, kind of remote controlled robots going into the lab to artificially do things, but having the human consciousness program the robots and having that intentionality. I wonder if it's possible to kind of link your two protocols, because this dropping off, whatever it is, 1/r squared, you didn't show a formula or some kind of plot for it, but whatever that, first of all, that'd be really cool to know what the dependence is of how it drops off. But is it possible to modulate that with intentionality? So kind of merging the passive device with the intentionality and really showing a difference between robots, humans controlling robots, and then humans actually engaging together, and what kind of differences there are in picking up on that. So just had that thought. Thank you.
That would be very interesting to study. Yep. Thank you.
If we made a robot with AI and it showed consciousness results similar to what has already been demonstrated by putting something near its head, well, I don't know whether we should jump for joy or freak out.
Yeah.
Right?
Yeah, our prediction would be, it won't be, because at least with the current AI machines.
With current AI, yeah.
Yeah, because there are no molecular networks. Biosimilar circuits might, might produce what you're talking about. Maybe we need, material that involves ring structures, polycyclic rings, which we heard such a lot about. So with pi electrons and those kind of things. So.
Right.
Okay, thanks again.
Okay.
And now we have a